This one right here, this question is a standard question that comes up near enough every single year, or some format of it comes up near enough every single year in the Nat 5 exam. It's everyone's favourite topic, trig equations. Simply put, this one's asking us to solve the trig equation 5 cos x plus 2 equals 1 for x is between 0 and 360 degrees. Now, if we think of this along the same lines as general algebra, so if I was to rewrite this as 5x plus 2 equals 1, that would be straightforward enough for us to solve. We'd subtract 2 from both sides, and we'd get 5x equal to negative 1. We'd then divide by 5 and get x equal to negative 1 over 5. None of these rules change when we introduce trigonometry. The only difference is, instead of an x, we've got a cos x. So there will be some extra steps involved, but the general algebraic manipulation stays the exact same. So 5 cos x plus 2 equals 1. We'd still do the same first step. So we'd still take away 2 from both sides, and we get 5 cos x equals negative 1. We then divide by 5, same as we did before, and we get cos x is equal to negative 1 over 5. Now we're at this stage, this is where the extra steps come into play. Once we get to here, we need to figure out what solutions we want. Now, if you think of the cos graph, if I was to do a very, very quick sketch of it between 0 and 360, so it looks something along those lines, and I was to draw a line going along from along at negative a fifth, you'd notice it cuts the cosine graph at two different places. So this is where another one of the big differences comes into play. If we've got a normal equation like this, we'd get a single solution. In this case, x equals negative a fifth. But this graph here shows us we get more than one solution in our range from 0 and 360 degrees, so we have to take that into account. Now at this stage, always do the same thing. Always draw a cast diagram, because what this diagram covers is, like we said in class, it will show you the areas where you're going to get your solutions for each of the different types of graph, dependent on the kind of number you're after. So, if I imagine that I'm looking at my cosine graph and I've got a negative 1/5, I'm not going to get a solution between 0 and 90 degrees because cosine is always positive. I am going to get a solution somewhere between 90 and 180 degrees though, because that's here, and then I am going to get another solution between 180 and 270 degrees. If I go above 270 degrees, it's always positive, so I'm going to get no solution there. What we do at this point is a standard set of steps. We ignore the negative and solve it for x. That will always give us a solution in this quadrant of the cast diagram here, and we can then use it to get the two answers there. So if I then say, right, I'm going to ignore the negative and go for cos x is equal to a fifth, I can solve it by then saying, right, so x equals inverse cos, so cos minus 1 of a fifth. And what we can then do is just plug that straight into your calculator and you get 78.46, and then it continues on. So let's round that to one decimal place and say 78.5. So that gives me a solution in this quadrant here. But we are not interested in that solution. We want the solution in these two quadrants here. Now what I can do is, if I get a solution in this one, let's say it's x, I can calculate a solution in any of the other three quadrants using this. For the quadrant with an S, what I can do is I can do 180 and I take away that x. That will give me the solution anywhere in here. For the T quadrant, I do 180 and I add on that value of x, and it will give me the solution here. And if I was looking for a solution between 0 and 270, I'd quite simply do 360, take away that value of x. I want these two solutions, so what I can then do is I can say, therefore, x equals 180 minus the x, so 180 take away the 78.5, or 180 plus that 78.5, because that will then give me the second solution that I'm after. And then it's just a case of calculating it. So what I can then safely say is x equals 101.5 degrees, or 180 plus 78.5 degrees, which will give me 258.5 degrees. So there we go. I've got my two solutions there. So I've got one solution at 101.5 degrees and another solution at 258.5 degrees. With these sorts of questions, it's the same standard procedure and standard set of steps. Treat it like a normal algebraic equation. The only difference is you'll have your trig function here, whether it's sine, cos or tan. Once you've got to this stage, use your cast diagram to determine which solutions you're going to use. Ignore the negative if there's one there, do the inverse cosine, tan or sine of it and get a solution. That solution will always be in this quadrant. Now if you want that solution, great, there's your first answer. You then determine the answer in the other quadrants based on 360 minus x, 180 plus x or 180 minus x for those. If it gives you a set number of decimal place to round it to, make sure you do that, otherwise I would tend to stick with one decimal place, job done. Make sure as well your solutions are within the range. Now this one I was happy enough to do 101.5 and 258.5 because my solutions were in the range of 0 to 360. If it limits it any more, maybe 0 to 180, this would be the only valid solution. But in that 5, again, you tend to have the same standard format, so it tends to be 0 to 360 degrees. These questions come up near enough every single year, but if you handle them the exact same way, you'll walk away with the marks every single time.